Hi everyone. In this lesson we will be looking at the chapter Trigonometry in IGCSE Additional Mathematics. Okay, but before we go into the content of this lesson, it's important to know the pattern of questions that usually comes out in the past year papers. There are usually three patterns of questions that occur for this topic. And what are they? Firstly, solving trigonometric equations. Okay, here you would be asked to find the value of the angle theta. Okay, so you have to solve the equation. Secondly, okay, that's what we're going to be doing in this lesson, which is to prove trigonometric identities. Thirdly, okay, the question relates, okay, to the graphs, okay, of trigonometric equations. So I have had some requests, okay, to do a video about proving trigonometric identities. Okay, so we'll be looking at a few questions from past year papers, okay, and I will show you, okay, step by step, okay, on how to get the answer. Okay, so our first question is from, okay, the 2012 paper, May-June, paper 1. Okay, and the question is, show that cotangent A plus sine A over 1 plus cos A equals to cosecant A. So how do we go about this question? Okay, there are a few general tips, okay, on how to prove or show this trigonometric identity. Okay, the first one is, okay, we usually denote, okay, the left hand side from the right hand side. So in proving, generally we start from the left hand side, okay, and we aim to change whatever is here to become whatever that is on the right hand side, okay, because there is generally more information to work on, okay, here. Okay, so usually start from your left, okay, and what can we do here? Change cotangent A, because cotangent A is cos A over sine A. Okay, so cos A over sine A. Okay, and now when you have two fractions, okay, on one side, generally we combine them, okay, or we make them into a single fraction, okay, which means making the denominators the same. So on the left, what can we do is, okay, we have to multiply this left hand side fraction, okay, with 1 plus cos A, okay, and this fraction we multiply it up and down with sine A. okay, so that we get the same denominator of sine A 1 plus cos A. Now since both of them are the same denominator, we can now combine them. Okay, so we have sine A 1 plus cos A, and we have the top which we can expand. Okay, so after we have made them into a single fraction, the next tip that we can apply is to choose the right identity to simplify, okay, or to shorten this whole thing, okay, so that it eventually becomes cosecant A, what is on our right hand side. Now if you look carefully, you will notice that cos square A plus sine square A will give you 1. So what we have here is cos A plus 1 over sine A bracket 1 plus cos A. Okay, and if you notice that we have the same expression top and bottom, it means they can be divided, okay, to give you 1. So what we get is 1 over sine A, okay, which is cosecant A. Okay, so what we have and how do we prove is start from the left hand side, apply a few general steps, like making the fraction the same, choosing the right identity, and having a look at your final result. So now let's move on to our next question. Okay, and if you guys would like to just pause the video at any time, okay, so that you can attempt this question first before we go through it together, please feel free to do so. Okay, so our next question is taken from October-November 2013. Okay, and it is a 4-mark question. Okay, so from the earlier question we already know, okay, that in proving, okay, we do not find theta. Okay, some mistakenly try to solve this equation, which is not right. Okay, all we are trying to do is to change the way the left hand side of this equation looks, okay, so that it becomes the right hand side. They are basically the same thing. Okay, so we know that this is our left, and we will start from the left, okay, and we must eventually arrive at a conclusion of 2 secant theta. Okay, so we have a lot more to work from the left hand side, so let's get started. Okay, so what have you guys done? Okay, so as mentioned earlier, it's quite famous, this kind of question, which is given 2 separate fractions, so we have to combine them. Okay, and by combining them, it means that we have to equate the denominators. So what do we have here on the left hand side? Okay, on the left hand side, okay, we have to multiply the top and the bottom with 1 plus sine theta. Okay, and for this fraction, we have to multiply the top and the bottom with cos theta, so that we get the same denominator, okay, of cos theta and 1 plus sine theta. This allows us to make it into a single fraction. Okay, so we can have a single fraction already because we have the same denominator. Nothing happens, okay, down here. Okay, but we can add the numerators of both the fractions. So what do we have? Okay, we have 1 plus sine theta, 1 plus sine theta, plus, okay, cos theta times cos theta. So we expand everything. We have a lot to work on here. So when expanding, okay, be careful, expand it, okay, as how you would expand in algebra. Okay, 1 plus sine theta plus sine theta plus sine square theta plus cos square theta, okay, over cos theta 1 plus sine theta. Okay, so what are we going to do next is we're going to try to use identities, okay, trigonometric identities, to make the expression shorter. Okay, so if you remember, the most used identity, okay, will be the first basic identity, sine square theta plus cos square theta equals to 1. Okay, and we see it right here. Okay, so this whole thing will give us 1. So we have 1 sine theta plus sine theta gives us 2 sine theta plus another 1. Okay, and we just continue everything. Okay, so we have on top 1 plus 1, 2 plus 2 sine theta over okay, cos theta 1 plus sine theta. Now always have an eye on what you want to achieve, which is we just want 2 secant theta at the end. Okay, and we know that secant theta means 1 over cos theta. Okay, so if you look here, we can factorize out 2. Okay, which allows us, okay, to divide. It cancels out each other to become 2 over cos theta. So 2 over cos theta is 2 multiplied by 1 over cos theta, and since 1 over cos theta is secant theta, we have managed to prove this trigonometric identity. Right, next is a question from November 2009, a paper 1. It's a 3-mark question. Okay, so please feel free to pause this video, okay, and try it yourselves first before we go through the solution. Okay, so what do we have here? Basically is, okay, proving or showing that, okay, our left hand side equals to the right hand side. So as we have seen in the earlier patterns, okay, we are going to start from our left, okay, and we are going to try to achieve the right hand side. Okay, so by looking at the left hand side, notice that we have 2 separate fractions. Okay, so we have to make them into a single fraction. This is one of the key moves that is always applied. Okay, so by looking at the denominator, okay, we can make them into the common denominator of sine theta cos theta. Okay, which means everything in the first fraction, alright, will be multiplied by sine theta. Okay, up and down. And everything in the second fraction will be multiplied up and down with cos theta. Okay, so that we have the denominator as sine theta, cos theta. Once the denominators are equal, this allows us, okay, to add them up. Okay, so our denominator is just sine theta, cos theta. Okay, and we can, okay, simplify the top and put them together. Okay, so sine times sine gives us sine square, cosine theta times cosine theta, cosine square theta. Okay, so how do we go on from here? Always remember, okay, choose the right identity. Yeah, and if you notice, okay, 70% of the time, okay, the first general identity will always be used, which is sine square theta plus cos square theta always gives you a 1. Okay, so every step carries marks. So just by using the right identity or by equating the denominator, making them into a single fraction, you get marks along the way. Okay, so keep on trying. Okay, each step will lead you to the next. Okay, so what we have here is 1 over sine theta cos theta. Okay, and sometimes students give up, okay, when they are so close to the final answer. Okay, just remember, you have to know all your identities. Okay, what does cosecant stand for, secant stand for? So we are just one step away. Okay, we can actually separate them, okay, to understand, or you can straight away move on to the final part. Okay, because it is actually 1 over sine theta multiplied by 1 over cos theta, and 1 over sine is cosecant theta, and 1 over cos theta is secant theta. Okay, so this is a shorter question, 3-mark question compared, okay, to the previous 2 that we have discussed, but generally it follows the same pattern. Okay guys, now let's look at one more question. This is taken from quite an old paper, 1991. Show that cotangent square theta minus cos square theta equals to cotangent square theta cos square theta. Okay, so feel free, pause, try it out first, okay, before we do it together. Sometimes, you know, there can be more than one way of achieving the result. Okay, so as long as you get it, it's fine. Okay, but generally keep, okay, to those steps, as we have discussed earlier, to prove successfully. Okay, so we're going to start from our left hand side. Okay, so we have our left hand side, which is cotangent square theta minus cos square theta. Okay, and this is what we want to achieve, our right hand side. Okay, so now we know that cotangent square can be either 1 over tangent square or cos square theta over sine square theta. So which one do we choose? Okay, so well, it depends, but I'm going to go for cos square theta over sine square theta. Okay, and now what do we do after this step? Usually same thing. If we have two separate terms, two separate fractions, and the second term is also a fraction as it is over 1, we make them into a single fraction. Remember, this is a very crucial step. Okay, so what is the denominator now if both were to be the same? Okay, since this is a 1, okay, this need not be changed. We can just multiply both the top and the bottom here with sine square theta, so that we have, okay, both fractions to a denominator of sine square theta. Okay, so now since both are having a denominator of sine square theta, okay, we can subtract the numerators. So this side nothing has changed, okay, but this side we have the product, which is cos square theta, okay, multiplied by sine square theta. Okay, once we achieve this step, a single fraction, then we're going to look at ways to make it shorter, make it smaller. Okay, it can be expanding sometimes, or in this case factorizing out a common factor. As you can see, we have a common factor now of cos square. Okay, so we can factorize it. Take it out. Okay, once we take out cos square theta from here, there is just 1. Once we take out cos square theta from this part, okay, we are just left with sine square theta. Okay, so knowing your identities, okay, is very important. Okay, because what we're going to do now is we're going to always have a look, okay, see the connection between what we have and what we want to achieve. Always keep an eye on your final end product. Okay, so I know that I have a cotangent square theta because cotangent square is cos square over sine square. Okay, so we have cos square theta over sine square theta, just to separate them so that we can have a look. And 1 minus sine square theta is cos square theta. Okay, this comes from the first identity. Okay, so in the first identity again, we have sine square theta plus cos square theta equals to 1. Okay, so by making cos square theta the subject, okay, we can also use this variation, okay, as part of our steps. So cos square theta, by changing the places, is 1 minus sine square theta. So we change it back here, and there we go, we have our result. Okay, so cos square theta over sine square theta is cotangent square theta cos square theta. Alright guys, so I hope this lesson has managed to help you a little bit. If you guys managed to learn something, please, okay, give a like, okay, or comment, okay, which part of additional mathematics you would want to see in the next video. Till then, thank you.